So in the last video we talked about exponential growth. Now we're going to talk about exponential decay. With exponential decay, your graphs in general are going to look like this. Because it's going to go down. It's going to get smaller and smaller. Okay, that's not touching. Pretend like that's not touching. Okay, if I draw it straight. There you go. So your exponential decay, of course, are going to come down, which totally makes sense. Now, if we compare this to exponential growth, it's going to look very similar. Y is equal to A, but now it's a decay, so what do you think is going to happen? Exactly, 1 minus R to the x, where A, of course, is the original or initial amount. R is the rate of decrease, decay or decrease. Okay. X is the number of intervals. Oh, whoops. Decimal. Hello. Okay. Intervals. Or the time periods of decay. Okay, so how much time has elapsed? The Y represents, of course, the amount after X intervals of decay, or a lot of times decay will also be depreciation. You'll hear that, like a car depreciates, or something depreciates in value. Okay, so here we go. Some students doing an experiment is known as the amount of a solution dependent on the length of time since the experiment began. This equation. Now, this happens a lot with cells. Cells decay or grow, and so in science you'll use this even more. Check with your science teachers and you'll probably hear it. They'll know exactly growth and decay if you haven't already done it in science. Okay, so here's our equation. It can be used to model the number of milliliters. Write this equation so we can write it out to see what our actual rate is. So Y is equal to, we have 50, and then it's 1 minus what to get to 0.6? 1 minus 0.4. Right? Because we got to 0.6, so we had to take 1 minus. So 1 minus 0.6 is 0.4, so this is 1 minus 4 to get 0.6. So what's my rate of decrease? Well, 0.4, which of course is equal to 40%. What does the number of 50 represent? Well, that was the original amount. Of the solution when the experiment, okay, so it was the amount of solution when you started the experiment, when the experiment began. Oops, oh my gosh, I can't even read my handwriting. Experiment began. Okay, what does X represent? Well, it's time. And what are we talking about as far as time? Milliliters per minute. Okay, so the time in minutes. And it's time in minutes, so it's the minutes since you began. So minutes since experiment began. Experiment, yep. Started, we'll say. Okay. If we substitute 1 in for X, what value do you get for Y? What does that represent? So let's do it. Y is equal to 50 times 0.6 to the first. So take out your calculator. 50 times 0.6 gives us 30. Okay. So, that's, since it started 1 minute after, so there's 30 milliliters after 1 minute. Or we would say there's 30 milliliters remaining of the solution. To the nearest tenth, estimate the number of milliliters of solution after 5 minutes. So, Y equals 50 times 0.6 to the fifth. Go. And does it say to round to the nearest tenth? So for this you got 3.88 blah, 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 blah. So round to the nearest tenth. So that'd be 3.9 milliliters remaining after 5 minutes. How is, oops, sorry, you didn't see that whole thing, but you probably figured it out because you're smart and you know how to use a calculator. How is an exponential decay situation different than an exponential growth? Okay, well, a decay, the original amount goes down, it decreases. Growth, the original amount grows. So, with exponential decay is the amount of whatever you're talking about decreases. It goes down. Hence the graph goes like this. Whereas exponential growth, the amount increases. So your graph goes like this. Okay? So this is decay, this is growth. Let's look at the homework. So here, x is 5, plug it in, round to the nearest hundredth. Suppose you purchase a car for $8,500. The car depreciates at an annual rate of 5%. Round your answer to the nearest cent. Use a formula for exponential decay to find the following. So on this, we're just going to model what is happening after X years. And then it asks you different questions. So we start off, what's our initial amount? 8,500. So that's our A. And then it's a depreciation. It goes down. Boy, do cars depreciate quickly as soon as you drive it off that lot. But this one's saying that it is at a rate of 5%. So 5% would be 0.05. Sorry, yeah, 0.05 because I moved my decimal point 2 places. So now if I take 1 minus 0.05 to the x, because R stands, what is the value of R? 5%, so that would be 0.05. I'm kind of doing these backwards, but that's okay. So my equation is 8,500 times 0.95 to the x. There's my equation. What does the x variable represent in this? It is the time in years, so the number of years. And what is it worth after 4 years? So what are you going to do? Well, x is equal to 4. So you're going to plug it in. So it starts off at 8,500. So we're going to plug that into a calculator. And you're going to round to the nearest dollar and cents. So it's going to be approximately $6,923.30. Okay? You'll do the next one. It's a decline. Follow that. This one, you're just plugging in x and y. It's just a good exercise on how to deal with exponents. So never a problem to practice that. And then the equations in 10 through 13 describe quantities that either grow or decay exponentially. For each equation, tell whether the quantity described grows or decays. So first you have to decide if it grows or decays, then tell the initial amount, and then give the growth or decay rate for the quantity. No, growth rate. Sorry, growth rate. So I want the rate. Okay, so here we go. I'll do a couple of them. So here we go. Look at this. Is this more or less than 1? It's more than 1, so this is a growth. What's my initial amount? That's A, 12,000. What's my rate? Well, remember, a growth is 1 plus the rate. So this is 1 plus 0.25. So what's my rate? Move the decimal point 2 places. I get 25%. See how that works? Okay, let's do 13. Nope, I'm going to do 11. So, here I go. Tell whether it grows or decays. Is this number greater than 1 or less than 1? Because that's what happens. If your growth is, it's a growth, if this value in here, this 1 plus r, 1 minus r, is greater than 1, and it's a decay, if it's less than 1. So is this greater than 1? No, less than 1. So this has to be a decay. And what's my initial amount? That one's always easy. Now, what is happening here? Remember, this is 1 minus the rate, and I equal it to 3/4. So what was my rate? So 1 minus what gives me 3/4? 1/4, which is 0.25, which is 25%. Hello, I wrote this one wrong. My initial amount is 26. Okay? Good. I'll let you do those other two. Let's see about these. Jim bought a car, depreciates, so you're just practicing. If it's a savings account, it pays an annual interest. If it's a savings, it's going to be a growth. If it's a loan, it's going to be a decay. Sit with the solution. Decreases. Okay, I'll let you practice those. Good. So if you have questions, you know where to find us. Make sure you check on Schoology to see what your exact homework assignment is. Thank you very much. And if you have any questions, you know where to find us.